Okay, the center mass frame is actually the frame in which the two objects, were they to stick together on collision, in other words, were the collision to be completely inelastic, it's the frame that's moving with the common velocity of those two objects after the collision. It's the frame in which, in an inelastic collision, the objects would come to rest. And it's then also the frame in which an elastic collision would result in the two objects reversing their initial velocities, okay? Reversing their before collision velocities. Okay, so if the two objects stick together, how do we analyze that collision? Well, that one's pretty easy. The u1 and u2, the after collision velocities, are both the same. So we don't have to call that u1 or u2, it's u. The two objects stick together, so they're going to be moving at with the same velocity, same speed, same direction. Okay, then we have the equation for conservation of momentum is just m1 times v1 plus m2 times v2. That's the total kinetic energy, or the total momentum before collision. Total momentum after collision will be the sum of the two masses times your after collision velocity, so that we can easily solve for u. It's just going to be m1 v1 plus m2 v2 over m1 plus m2. And these are vectors, so if you have two or even three components in your velocities, that's okay. All the components are going to conserve momentum in their own directions, okay? So we can easily solve this equation. Always this equation is easy to solve for u. And we can get the velocity of our center of mass frame. Then that's going to be our vref. We take our velocities, v1, v2, and we transform them to that system. Get our v1 prime and v2 prime. Okay? And then we just, for after collision, we reverse the velocities, and then we bring ourselves back into the original frame of reference, and there's the result of our collision. And it's an important way to understand collisions, and it's also important to understand various frames of reference. Many times in physics and engineering, we change our frame of reference in order to more easily see what's going on. And you can certainly understand that an elastic collision, especially if you tried to solve them using the equations, which is not that hard, but how it's much easier to understand what goes on in the center of mass frame, much easier to work within the center of mass frame. So it's one technique that we want to be sure we have. Now all I've said here is if the collision's elastic, pretend it's inelastic to find the velocity of the center of mass frame. That's what we did here. Then analyze the collision in that frame. And the analysis is really simple. The two velocities simply reverse. The two vector velocities reverse. The velocities reverse if the collision is elastic. Then we transform back into the original frame.